This is going to be a video on how to find the roots, all real roots, of a given function using the rational roots theorem and synthetic division. Okay, you might use some factoring if it happens. Great, but I'm going to have this equation, and so on your exam you'll be given an equation like this, or maybe, well, it'll be different. But you should be able to use the same process for this or for any polynomial function to figure out the real roots. So we're going to start off with the rational roots theorem. Actually, let's start off with the fundamental theorem of algebra. So the fundamental theorem of algebra, if you forgot, tells me how many roots there are for a function. I know for the fundamental theorem of algebra that there are 3 roots here. So my degree is 3, so that means I'm going to be looking for 3 roots. So I know that there are 3 roots total. And I know this because of the fundamental theorem of algebra. If you forgot that, look it up real quick, it'll tell you. So there should be 3 roots. My rational roots theorem tells me that I need to look at the first leading coefficient, and I need to look at the last coefficient over here to help me find them. So something that Jessica said today in class was using a and z for that. So I'm going to say that a equals 1, so that's my leading coefficient. My z, which is my last coefficient, is 20. And now I need to find the factors, the integer factors of these 2 numbers. Okay, so I'm going to do that. I'm going to say that the integer factors of 1 are only positive and negative 1. You will always have positive and negative. There's never just negative 1 or positive 1. It's always both. My integer factors of 20, it's a little bit of a longer list. I have plus and negative 1, plus minus 2, plus minus 4, plus minus 5, plus minus 10, and plus minus 20. Okay? So now, these are my possible, these are the factors of these, but I'm really looking for combinations of z over a. Okay? Z, well, I'll put z star over a star. So a star are these ones, so this is a star. So these are a stars, and these are z stars. Z stars. Okay? So don't just do 20 over 1, do these factors over that one. So don't confuse those 2 things. So I'm going to start off my possible, so these are my possible roots. Possible roots. My possible roots are z star, so I'm going to start off over here. So plus minus 1 over plus minus 1 is just plus minus 1. Plus minus 2 over plus minus 1 is plus minus 2. And you'll notice that it's actually just going to be the same list because my denominator is always 1. Now if this was a 2, I would have plus minus 1 over 2, plus minus 2 over 2, which is just 1, and you would do that way. So all possible combinations. I won't give you a huge list for the exam because I know it's a pain in the butt. Okay, but for this one, we'll do this list and we'll figure it out. Plus minus 10, plus minus 20. So these are my possible rational roots to this equation. Okay? Now what we need to do is we need to start checking to see whether these are roots. As we talked about in class, we've talked about in class multiple times, is that we know that one of these is going to be a root if when we plug it into the equation, if we substitute this in for x, it gives us 0. Okay? So you can do this by hand. You can do this on your calculator, which is a lot faster. That's how I would recommend doing it. So what I would do is I'd plug 1 into each of these. So I plug 1 in. F of 1 it's 6 actually if you do it on your calculator. So you would do it on your calculator and know that basically what I'm doing is I'm checking to see whether f of 1, is it 0? No, it's not. F of negative 1, is it 0? No, it's not. If I keep on doing this, I would actually get to f of 2, which happens to be 0. And I get that by, if I plug 2 in for each thing here, I'd get 0. So when I do that, once I find one that gives me 0, I know that we're going to say that x equals 2, right over here. So x equals 2 is a root. I know this, okay? Once I've found 1, I mean you can keep on doing it, but once I've found 1, what I would recommend is once you find the first one, is you're going to do synthetic division now. okay? If you forgot synthetic division, look up the quick video on it. It's not a long thing, it'll come back to you, okay? So I'm going to set up my synthetic division. 2 is my root, so I'm going to write it here. Then I'm going to write my coefficients of that function over there. So I have 1, 1, negative 16, and 20. So 1, 1, negative 16, and 20, okay? And when I do this, I'll know that it's a root. This is double checking if I get a 0 underneath this 20. So I'm going to drop the 1 down. I'm going to multiply it by 2. That gives me 2. 1 plus 2 is 3. 2 times 3 is 6. Negative 16 plus 6 is negative 10. Negative 10 times 2 is negative 20. And 20 plus negative 20 is 0. So this is good. So this is my remainder. I've checked that off. And now I have right here are the coefficients of a new polynomial, okay? And I know that since I started off with a degree 3 polynomial and I divided it by a degree 1 polynomial, I'm going to just lessen the degree by each one. So instead of writing x cubed, this is going to be x squared plus 3x minus 10. So if I take this away now, here is my new polynomial. So I have this, okay? This is my new polynomial. What I really did there, so I pulled an x minus 2 out. So I divided by x minus 2 because I know it's a root. This is one of my roots now. So now I know that x minus 2 times this would give me that original function, which makes perfect sense, okay? Once I get to here, I need to check whether or not I can factor it, okay? It so happens that I can factor this pretty easily, and I'll show you in just a second. If it was not factorable, or if you were like, I don't know what to do here again, what you would do is you would find another factor. If you kept on going through, you could either redo the rational roots theorem and have a shorter list, or you could just keep on checking these, and you would eventually find that 5 is another factor. You would do the same synthetic division process and get to the same point. Doesn't matter. It just so happens that this is factorable by the normal method that we would use. I can see that 5 times negative 2 gives me negative 10. 5 plus negative 2 gives me 3. So I know that this equation right here factors into x. What do we have? So I should have a plus 5 and a minus 2, okay? So now I know that if I did all these things together, I have x minus 2, so I'm going to write that again one more time. So my final factored form is x minus 2 times x plus 5. And since this is another x minus 2, I'm just going to write a squared up here because I'm multiplying them together. Doesn't matter. So this is how we would move from this original form here, so this is the general polynomial form, to factored form, where it looks like this, okay? And now, if it's asking for my roots, I need to go back and look at these just like we would normally do it. I'd say that I have a root at 2, and it actually happens twice because I have a squared there, so I have a root at x equals 2, 2, and I have one at negative 5, okay? So this has been a video on how to find the roots and the factored form and roots of a polynomial when we start with it in expanded general.